We say that what are lateral earth pressure? The lateral earth pressure determination is needed in the design of many types of structures and structural members. Common examples being retaining walls of the gravity and other types, sheet pile, bulkheads, basement walls of buildings, and other walls that retain earth fills and excavation trenches. Often the lateral pressures are difficult to evaluate. However, lateral pressures can be estimated accurately using earth pressure theories, such as the Rankine's theory, the column theory, and other theories. Taylor 1964, Tench 1964, and Das 2007. They all came out with on investigations into how to investigate the performance of walls retaining walls are walls that are provide lateral support for oil or rock. In some cases, such as basement, as what basement walls, vertical loads. It may also support vertical loads. The more common types of interlocking concrete members that form cells which are then filled with compacted soil. Walls commonly used to retain soil and slope conditions, which if exceeded resulting from the lateral forces exceeds that exerted by the self-weight of the wall. We see the factor of safety against overturning walls should be at least 2. Now they say that the factor of safety against the overturning wall should be 2. So you see how the overturning wall look like. Then we have the sliding walls. The sliding walls. The sliding walls. The sliding wall, the wall will slide if the lateral thrust exceeds the factor of safety against sliding should be about 2. We're also telling you the factor of safety against the sliding should be about 2. So we have a sliding being like this. Then we will get to. Then we have bearing on ground. Bearing on ground. The normal pressure between the base of the wall and the soil beneath can cause a bearing failure of the soil if the ultimate bearing capacity is exceeded. Usually, the allowable bearing pressure will be 1/3 of the ultimate wall value. Note that the pressure distribution across the base is not constant. It's not constant. So, now we also have the rotational slip. The rotational slip. The rotational slip is also calculated or given as this. The wall and a large amount of the retained material rotate about 0.0 if the shear resistance developed along a circular arc is exceeded. The analysis is too complex to include here. So you can also see here in your picture where the retaining wall, the rotational slip, how the diagram is also shown. Shown a rotational slip. Shown a rotational slip. So the rotational slip is also shown there. Then wall material failure. The wall material failure will say that the structure itself must be capable of withstanding the internal stresses set up. That is to say, the stresses must not exceed allowable values. The stresses must not exceed allowable values. And the factor of safety used here depends on the material. Now they're saying that the factor of safety used here must also depend on the material used in a construction. The factor of safety used here depends on the material and the level of the designer's knowledge of the loads actually applied. Over here, you need an expert in a sliding wall, an expert structural engineer who has invested his time in the designing of sliding walls. You know, for the structural engineers, we have categories of them. Some of them specialize in bridges. Some specialize in structures, building. Some also specialize in walls, retaining walls. So you go in for the one that are specialized in retaining walls. They are to tell you the factor of safety to use. We will look at the material, they will examine the material, then they will tell you the factor of safety to use, right? Naturally, both shear and bending must be considered. When designing this kind of walls, you must consider also shear and bending. But the most critical condition is likely to be tension failure of the front facet. Front facet. Joint failure in block wall. We're seeing it over here. And now we also come to the gravity walls and dams are dependent on the effect of gravity largely from the self-weight of the wall itself for stability. Gravity walls and dams are dependent on the effect of gravity largely from the self-weight of the wall itself for stability. Other types of wall rely on a rigid base combined with a wall designed against bending to provide an adequate structure. To provide an adequate structure. To provide an adequate structure. So the gravity wall also over here, when you can see from the picture here, the gravity wall is also saying that over here, as you can see, we are showing the tension bending failure zone. This is the tension bending failure zone. The force is being applied here and it's tearing this thing apart. So you can see that the wall, the column wall has tilted a bit. There has been a tilt between the column walls. Okay, there has been a tilt between the column walls. So this is showing you the gravity walls, where we have also